Hello everybody, my name is Moltenon, and today I've prepared a very cool tutorial for you. As you can see, we're going to create a radar effect, and in fact we're going to create three types of radars. And the first one I call the radial, as you can see right here. We're going to create a landscape radar, which looks something like this. And as you can see, we have this scanning. The scanner goes through a landscape, and the last one is linear radar, and they're all based on the same idea, so they're basically very similar to each other. And since you already know what we are going to do, I'm going to tell you what we are not going to do. And we're not going to set the keyframes for this aircraft's opacity, because we're going to write a simple collision detection, if you can call it like that, and the opacity will be controlled by the expression. And we're not going to create keyframes for this scanning line to be moving in circles, or to just go from the center and then go from the center again. We're only going to animate one cycle, and then we're going to use the expression to loop this cycle. And we're also not going to do the beeping sound in layers. So normally we would create a beeping sound and then place a new layer each time this scanner line and this aircraft collides to create the beep sound. And as you can see, I have only one beep layer, and this is also automated, so we don't have to create keyframes for that and any types of animation. So basically this is all about expressions, and I know that some of you don't like it, but it's really pretty useful. So if you don't like expressions and don't want to go into them, then just watch the tutorial or just download the project file and just forget about expressions. Just use, copy, paste, and do whatever you want with it. But I really encourage you to take a closer look on those expressions. So let's begin. Let me just create a new project. And first of all, we're going to create our radial radar. So let's make this, I don't know, 30 seconds long is okay. And let's turn the render mode to half, because we are working in 50% anyway. And let's call this radial radar. And let's create a new solid. Doesn't matter what color it is, make it comp size, and let's call this one grid. And now let's apply the grid effect. Pretty simple, right? Okay, so far so good. Now let's change the color to green, or greenish, dark green maybe. I think this one will do. And this is it basically. Now we have to create this scanner line. So let's create a new solid again. Let's call this scanner, and let's apply the beam effect. And I will just explain why we're doing it like this. And the reason for that is that we're going to apply, at the end, we're going to create a new adjustment layer and apply the polar coordinates. And we are going to convert rectangular to polar. See what happens? It's just like you would warp a square into a circle. So this is how it looks, and we are going to use this to create all the radars. Of course, you could create these graphics in Photoshop or whatever, but I just like to stay in one application as long as I can. So in this case, we're going to use these polar coordinates to create the radar. Let me just turn this off for now, and let's go back to our scanner. Let's change the color to green, and the outside color to green also. And let's set this to 0, and let's set this to 800. So now we have a line from left to right. As you can see, we now have a closed circle, and now we need this to be moving in the y-axis. So let's just create a slider for that, because we don't want to animate these keyframes, because we would have to animate a starting point and ending point, and when we apply the slider, we only have to animate the slider, and we only have to do this once. So we already have a slider, and we have to set the expressions for those two parameters, so for starting and ending point. So let's just alt click on the stopwatch, and all we have to do really is to define what the slider is, just to make things easier. So let's type in SLD for slider and use the pick whip to point to the slider, and we're already halfway through this expression. And now we need to set the starting point to be 0, because we always want this to start at this side, and the y parameter we need to set to whatever the slider value is. And that's it. As you can see, it already takes effect, and we have to do the same thing for the ending point. So let's alt click on the stopwatch, type SLD for slider, use the pick whip to point to the slider, and the ending point should be 800, because we want it to be on this end, and the y value must be whatever the slider is showing. Ta-da! That's it. Pretty nice, huh? Let me just turn on the polar coordinates transformation. Sweet. Okay, now let's increase the thickness. So let's type in 20, maybe? Nah, even more, I think. 35. Okay, and let's change the softness to 100%. And now we're going to create this animation, okay? So let's just move the slider to -80, for example, so we can have just a little delay before the slider shows itself again. So -80, let's move to 5 seconds, for example, and instead of typing 800, we're going to type 880. So we have no scanner line visible at this point, but when we move, it shows itself and then it disappears. So let me just render this out. Nothing very complicated. Okay, so it looks like this, and now we would have to copy these keyframes so it just moves constantly from the center, from the inside to the outside. But instead we can just type an expression that we can find in this little arrow, and we would have to go to property and then choose loop out duration, and that's it, I think. As you can see, it already takes effect. We only have 2 keyframes and it's looping pretty nice. So the next thing, I think we can just tweak this up a bit. So let me just call this polar, because those are the polar coordinates. That's right. Let me just twirl this for a second, and now we're going to create a new adjustment layer and let's call this transform, and let's apply the transform effect. And why is that? Well, basically we don't have to do this, but as you can see, this polar coordinates created this circle from each side. It just fits the composition perfectly, and I don't want that. I want it to be a little smaller, and I don't want to use scale on every layer, so I'm just creating an adjustment layer with the transform and scale set to 90%, and that's the easiest way to do it, I think. And okay, so now I think we can just make this look a bit better. So let's just create a trail for this scanning line, so it leaves a trail behind it. So let me just go to time and echo, that's right. And let's set the number of echoes to 10, and start intensity, let's leave it at 0.8, I think. And the decay, we want to set decay to 0.7, so it fades out a bit, or maybe 0.8. As you can see, it leaves a small trail. Maybe let's just increase the number of echoes. It should make this a bit longer, maybe 30. So, okay, as you can see, we have this trail of this scanning line, and this is good. And we could also apply a glow effect to the grid, and let's do it. Let's turn the threshold down a bit, and let's set the colors to maybe light green like this one, and dark green like this. And let's set the colors to AB colors, and now we need to turn the threshold down again and increase the radius and intensity as well. Okay, that looks okay. So now let's create our target, right? So let's create our aircraft, and the aircraft is going to be 100 pixels by 100 pixels, and duration doesn't really matter. Well, it has to be the same length as the composition of this radar, so let's just leave it at 30. Let me just zoom in and create a new solid. Make comp size just to make sure, and let's use the pen tool to draw this aircraft symbol, which is going to be something like this. And now let's press Ctrl A and Ctrl T to move this around, maybe to scale it a bit, just transform it so it looks okay. I think we can leave it like this. And now let's apply the stroke effect. And paint style to paint on transparent, brush size 4.2 or just 4, color green, of course. Let's set this to true green. Okay, maybe let's increase the softness, so let's turn the hardness down. Much better. And I think we're good to go with this one. So let's call this aircraft. And we can close this timeline for now, and let's drag it in here. And as you can see, we already have our aircraft in position. We can also adjust the anchor point, so we have the anchor in the middle. Okay, I think that's good. And let me just close this down. And now we can set the auto orient to orient along path, because when we're going to create the keyframes for this aircraft's position, like so, you already see what happened, right? It rotated itself to look towards the way it's going. So this is okay. You don't have to do this, but I think this is pretty cool. Okay, so let's leave it like this. And now the whole trick is to make this layer visible only when it collides with this scanning line. So right about here. And then, after the collision, we want this to be fading out till the next collision, right? And you could, of course, animate it by hand, but just imagine creating all those keyframes. And in fact, what if you would have to, just, for example, make this scanner line going slower or faster, then you will have to readjust the position of the keyframes and many stuff that you really don't have to do if you're going to use an expression. So we're going to use an expression. So basically we're going to create an expression for the opacity parameter, right? Well, not exactly. I'm going to show you what's going to happen when we do that, but this is not the right solution. So let me just copy paste this this expression that I've came up with. I'm not going to explain it because I'm not really good at math, and when it comes to explaining to someone what my sick and twisted mind came up with, it's really not a good idea. The basic idea is that we are looking at the distance between the aircraft and the middle of the grid, and then we are looking at the scanner position, and to be more precise, to the slider value, and then we just check if the values are more or less the same, and if there are, we are just setting the opacity to 100, and if they're not, we are setting the opacity to 0. And this should work. Let's just scroll through the time. Yes, as you can see, we have a collision detection going on in here, but the aircraft disappears just after the collision, and we don't want that. We want this aircraft to be fading. So the next logical step is to apply the echo effect, right? Well, not really. Well, you're of course right, but this won't work. I will show you why. And let's just apply the echo effect on this, and whatever. Let's just set this to number of echoes 500, so we have a really long fading time, 0.7, and here 0.96. So this should fade out really slowly, and as you can see, it doesn't. And why is that? Because the opacity of the layer is set to 0, and what that means, it means also that this echo effect opacity is set to 0. You may think of it like that. And how do we get rid of this? Well, we could try to write an expression that would set the opacity to be fading after the collision, but there's really a much simpler way to do it. So let's just get rid of this expression. I mean, let's just cut it from this, so Ctrl X, and now let's apply the transform effect, which is going to solve our problem. And let's move the echo below, and let's set this opacity, which also controls the opacity of the layer, to be controlled by the expression we've just copied. And this will work just fine, as you can see. And why is that? Because the opacity of the layer is still set to 100%, but the opacity is controlled by the transform effect, not by the layer itself. And this is the solution for the problem. And I think that's it, basically. So let's just do a quick RAM preview of this. Okay, so this is how it looks right now. As you can see, everything works pretty nice. We have a collision detection, and now we're going to do the most exciting thing. We're going to do a sound trigger. And if you've been working in After Effects, you would probably think of this like creating a nice sound in Adobe Audition, for example, and then just placing multiple instances of that sound along the timeline in place where the aircraft collides with the scanner line. And this is of course a good approach, but like I said, what if you'd like the scan cycle to be shorter or longer? Then you would have to rearrange the sound instances along the timeline, and this might be really very time consuming and just not really convenient. So in this particular case we can do a small trick. So let's just create a new null object. I think null object would do just fine. Let's call this beep, and let's go to audio effects and let's generate a tone. Ta-da! These are the frequencies, and I found that the best way is to leave the frequency 1 to 440, and let's apply the modulator. So we have this a little vibrating effect going on in the sound. Let's leave this at default, and let's add the reverb, and let's leave that to default also. And this is it really. Now all we have to do is set the level, which is the sound loudness, you might think of it like that. We need to control this with an expression which will be driven by the opacity of the transform effect applied to our aircraft. So let's just alt click on the stopwatch and let's type in you know what, let me just go to this aircraft and lock this palette so we can use a pick whip tool, and let's create a variable called OP for opacity, and let's use a pick whip to point to the opacity, but I'd like to control the maximum loudness. So let me just drag a new slider. Let's call this maximum, and let's just create a variable for that. So let's call this maximum equals, use the pick whip to point to the slider, and now we're going to use the linear transformation linear function, and we're going to set that, say that take the opacity value from the opacity slider from the aircraft, which range is 0 to 100, and transform it to the range between 0 and the maximum value of our max slider. And that should be it, but I've probably made a spell error. That's right. Okay, now let's just look for a keyframe where the collision is taking place, and let's see how the level is going to change. Well, it doesn't change because the slider is set to 0, so let's set this to 20, and we already see that we have a 20 value in here and 0 in here, and that's good. If we will set this to, for example, 50, we should get the same effect. I don't know why this doesn't update in here, but I guess this should work. Let's just do a quick RAM preview. Okay, let's see how it works. Well, it works pretty nice. So I guess we're finished with this one. So now let's move to the linear type of the radar. So basically we just have to duplicate this composition, and let's call this linear radar. And let's open this up. And the first step is let's just turn the beep sound for now. The first thing is we have to change the scanner type, and the scanner type, you know what, let me just turn the polar and everything else, just let's turn this off for now. We need this to be going from left to right, and this way we would get this linear type, you know, just the scanner line will go in circles. And to do that we just have to change these two expressions. So we need them to go from the slider value and 0 to slider value and 800. Right? Right. And this is all. And now we don't need this gap. We want this to go in circles all the time. So let's set this keyframe to be maybe not negative 80, but for example 10 or even more, because we want to see the echo. So let's set this to 50, for example, and here we can leave this at 800, I think. And no, that's not right. Let's set this to 0. And this looks okay, I think. Okay, so now let's apply the polar transformation and let's turn all the effects back on. So the aircraft and transform as well. And as you can see, we have this rotating line, which is pretty cool. And now we need to change the collision detection expression. So let's just twirl down the opacity in here. And like I said, I'm not really good at explaining math, especially in English, so let me just paste the code. And basically what this does is it converts the slider position to degrees, so from 0 to 360, and then we are trying to find where the point intersects. So we are trying to figure out the point on the circle, and in this case, on this frame, the radius of the circle will be this distance. So we are looking at this circle and we're trying to find if the aircraft intersects with this circle in a given range, so with some tolerance, right? Okay, I hope I've made myself clear, but I probably didn't. Anyway, this expression works. It took me some time to deliver it, so I just hope you can appreciate it. And let's just find out. Okay, the aircraft is gone. Now, yes, it shows up. Pretty damn cool. And now we can turn the beep back on. We don't have to modify the beeping layer because the names of the layers are the same, so the expression is still working. Let me just do a quick RAM preview for you. From this point, for example. Okay, let's see how it looks. Cool. Okay. So the linear radar is already built, and last but not least, we're going to create a landscape radar. So first of all, we need a landscape. So let's create a new composition, 800 by 800. Let's call this landscape. And let's create a new solid. Never mind the color. Let's apply the fractal noise. And let's leave it at defaults, and let's apply the threshold. That's right. And maybe something like this should do. Okay, let's leave it like this. And let's duplicate our radial radar, for example, because we can build the landscape radar from the linear or from the radial, so it doesn't really matter. But the radial looks much cooler, I think. And let's call this radial landscape radar. Okay, let's open this up. And now let's just drag the landscape instance to here. Let's see how it looks. Okay, that's fine. And let me just open this. And we are going to drive the alpha channel of the scanner from the landscape. And to do that, we are just going to set a track matte to Luma landscape. And you already see how it works, and it works pretty well. But we also like to see the landscape underneath the scanner. So we just have to drag another instance and just, maybe below the grid. And let's just colorize it a bit and turn the opacity down. So press T on your keyboard, set the opacity to 50, or even less, let's say 30. Let's apply hue saturation. You know what, let's turn the opacity back to 100 and let's use the hue saturation lightness to change how it looks, and we can now apply some color to this. Let's set this to bluish color saturation. Something like this would do, I think. And we can also apply a glow effect, for example. Stylized glow. And let's set the threshold. Okay, and I think maybe that's not as pretty as it looked when I showed you the original radar project that I did, but you get the idea. The colors and all stuff like that just doesn't matter. It's not the final effect, it's just the way to achieve it. You can now, you know, adjust the colors, glows, radius, speed, whatever. And but you know what, I'm still going to turn the lightness down a bit because this is way too bright. Negative 90. Okay, that's much better. Negative 80 maybe. Okay, let's leave it like this, and this is final. Okay. So let me just do a quick RAM preview of this one. Okay guys, so I guess that's it. Once again, my name is Maltenan, and you can find my other tutorials on www.maltenan.com. If you like this tutorial, I would really like to see some responses from you, so just if you can, please take some time and tell me what you think in the comments area for this particular tutorial and for the other tutorials also. So once again, this is Maltenan. You can find my tutorials at www.maltenan.com. I hope to see you soon. Cheers!